Hello everyone, hope you all are doing very well. One of the biggest advantages of using Python programming language is that you can apply the object-oriented programming while writing your Python code. Very first, we just learn how to create the class without even knowing any properties associated with it. Means no methods, no variables, just a class, and that's the foundation for us. Then we start growing our learning by adding the methods to it, then how to instantiate the object where we could access the methods available in the class. In the step number 3, we actually learn very first time how to add the class properties. The class properties are very important aspect of the class because that is what made that actions available on the class unique to whatever object is instantiated, depending on what type of properties that object is setting. In the step number 4, we actually learn how to create the various properties associated to the class so that when the object is going to instantiate, that object has the unique properties associated with it. It means when the object is going to be instantiated using the class, at that time the properties you need to provide during the initialization as well as the instantiation, and those properties are going to be giving that object the uniqueness related to that particular class, because multiple objects can be created, and based on the instantiation property you can actually set up your own object unique to your requirement. But in order to make it happen, you really need to write more methods in your class, and that is what we have covered in step number 5, where we learn how to apply the methods such as configure to make sure you can set up the whole class structure depending on your object requirement. Up to step 1 to step 5, we are using a live problem such as creating a class which perform the machine learning, and the methods such as training, configuration, and properties such as supported algorithm, applied algorithm, selected algorithm, whether we support AutoML or not. So we actually take these step 6 onwards, whatever we have done from step 1 to step 5, while we have created our class step by step in the baby steps to make sure we understand everything correctly and effectively. So step number 6 is the time where we actually learn how to make sure that we have proper understanding of initialization as well as the creating a new instance. So the role of init as well as the role of new keyword comes into the existence. Means using with these two different keyword, you can create classes where you can select, depending on your choice, you could instantiate either class A or class B. So the example is that using a control box class, you can actually either instantiate the machine learning class or you can instantiate the data processing class, and choices you are going to provide as well as the proper parameters. So instantiation can be done specific to your target class. That is what in step 6. The step 7 is the place where we actually learn the inheritance part of our class. Inheritance means how you are going to create multiple of classes and take the property from parent class and apply all those property into your child class. So inheritance with multiple types of child classes, different properties such as passing with only parameters, such as with initializer or not initializer, we have learned in step 6. And step 7 in step 7 and in step 8, we actually link the multiple classes in the parent child and the grandchild as well as the grandparent relationship, and that is what is part of step 8. The step 9, we actually learn the class creation using a very different way, using the type keyword. So how you can create a new class, and you can actually add multiple base classes when you are creating a new class, and how you can chain your methods available in those base classes. That is all covered in step number 9. And finally, the step number 10, we actually learn the use of data classes. Means if you do not want to use the initializer using underscore init method, you still need to provide the parameters. However, if you are not interested in using the init method, you can actually use the data classes to avoid use of init, and you can set up your class according to your object need. So all these 10 steps which we are going to cover in this video is designed for anyone who would want to learn how to write their Python code outside procedural pure class based, and figure it out how to start and how to get expert using the object oriented programming. The higher Python versions you are going to use, for example 3.7 and above, most of the functionalities available in the object oriented programming is available for you. If you go 3.10, 3.11, you are going to even get more support for object oriented plus others. However, as long as if you are using 3.7, you can take the full advantage of object-oriented paradigm in your Python code. Even when this functionality available in Python, most of the Python programmer, they do not write the code based on object-oriented programming paradigm. Instead, most of the code is written procedural in Python. Two big issues are that not everybody is able to apply the object-oriented methodology or the paradigm, whatever programming language they would want to use. First, it means the understanding of concept available in the object-oriented programming. First, second, applying them in their target language. So this video is created for those who have basic understanding of object-oriented programming paradigms, but they want to know how they can take that knowledge and apply it in Python. So this video is going to show you that how you can start writing classes in a very basic single or two line of code, all the way to make your classes extensible in 10 different steps. So the complexity in each steps grows higher and higher, and by the time you hit these all 10 steps, you actually have very good idea how you can apply the object-oriented programming, mainly writing the class, defining your parameters, creating your methods, and then by using various functionalities available in Python programming language, you can master yourself to write your code in Python by using object-oriented programming paradigm. My suggestion would be that watch this video from start to finish. That will help you writing the code based on class. Plus, it will also help you understand why you are writing in this way. What are the advantages of each step? And as you grow higher and higher steps, I believe is that the various things which you are going to see in this video will be helpful to move away from procedural programming all the way to write the object-oriented programming in Python. So before we try to write any single line of code, we need to get the basic idea about the class. First thing, class is nothing but a concept. So if you are trying to write the procedural code, you start just defining your variable and you write your methods. Versus when you are trying to write your code in class, first thing you need to stop writing any piece of code and think about class as a concept, which is a collection of various properties. So properties for the classes are variables and methods. Variable, what shape your class. Methods, what the action or what the functionalities a class provide. Taking your all the class properties and combining them with method is become your class. And that's where I would suggest anyone who is listening and watching this video, they must not write the code. First, they try to conceptualize what they want to do. For example, if I am trying to create a class, I'm not going to write a code, I'm just trying to create the class. So if I'm trying to create a class called X, I need properties which shape my class. Then I need methods, what action my class is going to perform. So if my class is car, very common example, properties are number of wheels, a steering type, left or right side, total number of windows, total number of seats, total number of front lights, back lights, etc. What my car is running, how it runs is a starting method. Those are the method will become our methods. If we go a little more practical and say our class is machine learning. So if our class is machine learning, then the properties will be, is training data available, is test data available. We just need to make sure. And our properties will be algorithm types, supported algorithm, auto ML. Do we have a pipeline? Do we have the ML ops functionality? Those properties. And methods will be perform training, perform validation, add data to your feature store, validate your data, validate your model, perform scoring. Those all became methods conceptually. So before you write a single line of code, you must stop yourself and conceptually think what you are going to do. And that's a very big difference between procedural versus object-oriented code. So now in Python, when we learn very first step of defining the class, let's go ahead, create a class called ML box. That's our class. And as soon as you are going to define your class, basically colon, where you are defining various properties. So you already learned that you need properties, you need method. But very first step, we don't have anything, but we want to think the class as a concept. We have a keyword called pass. It means define a class, but there are no properties associated with it. No variables, no method. That's very dumb class. Now if you remove this even main part, run your code is still working. There is no change whatsoever. If you enable your main, your code is going to print the hello, because that's what we are trying to print, hello. And there is our ML box is defined. If we put a breakpoint here, run our code, look into the special variable, basically the variables which are internals, you will see that ML box is actually defined within the special variables. So you created the class, but a class is useless if you cannot use it. Means to use the class, you need to instantiate the object. You are going to define your object. So your class object, let's use this is the ML object we have, and we need to set it up based on ML box. Now you see that I am defining ML box this way, and I will define another object called ML object 2, and I'm defining as the class. So we have already seen this means that this class is equal to this class. So ML object is actually the class of type ML box. ML object 2 is actually the instantiation of this class because we have defined it clearly. Now if we put a breakpoint here and we run our code, you will see that at this point ML object first is actually a special variable, because the whatever the ML box is, same is ML object. However, when we go to line number 2, now you can see that ML object is not type of ML box, but ML object is actually instantiated from the ML box class. And that's a very big difference when we have used the initialization of these two, ML object and ML object 2. Once again, they both are same. They just classes. Here ML object 2 is actually the instantiated object from this ML box class. However, because we do not have any method, so we cannot call through this object. And that is a very good segue to learn the second step in our class. So that's the summary of our step 1. So in step 2, we are going to remove this pass and we are going to define a method in our class. So we will say define training is a method for our class, and here we will say print ML training is in process. That's the method. And if you see here, there is a warning. Warning say that this method is actually static. Static in a sense because this method has nothing to do with any other property with the class, no relationship. That's why it can be static. So one thing is that when you, in future, when you learn everything about class and you define a method which is inside the class but has no dependency on the property, you can actually call it a static method, like a static method, and it says that even this method is defined inside the class but is static. But right now, for our purpose, we definitely want this method and as it is. We do not worry about this warning. So we have defined a method. Now we have these object, ML object 2. At this point, we can actually say the second object, which is the type of ML box, I would like to perform the training. So this instantiation happened. It means this object was initialized based on what our class configuration was. No, we do not know a lot about it, but we know that this class has been instantiated in this object, and now because this object instantiated from the class, it can call the method, and we have one method. It means visibly what we have done, we have taken a method here and added in our class, and these are all our class methods. So in our class we have a method and we have added this method, and this method is training. That's our class look like and training. Now if you run this code, you will see that breakpoint first hit. We have already seen up to here, run first. This code ran and message was printed and then hello. If you take ML object and if you say ML object dot training, at this point, if you see here, you can make a call to training object because they both are classes. So you are making a call to this training method. However, as you see here, this warning proves that there is no instantiation of the class happen to make this object work. So if you would want to make it work, you actually have to provide the class, and you can say actually this is the type of class ML box. Now it says that, oh, actually, no, I do not need the class. I really need the instantiation from the class. So how you could solve it? You take this whole code, just an example. You move this code to here. Now you say that this training is actually type of ML box 2. Now your code is going to, let's run first. Now you see that ML training is in progress. ML training is in progress. And actually this is writing and this is writing same method. Because we have provided this. If you do not provide, it is not going to work. It's always going to complain. So if we debug this code, you will see at this point, the error happens here. So what's the gist of this step is that you are not going to define a class this way. This is not the correct way to do it. The correct way to do is this way. And this is not a good way to do it. However, whenever we have used the class instantiated object past here, it did work. However, this is the correct way to do it. So that is our step 2. Correct way to instantiate the object as well as making the call to the class methods. So this is the summary of our class specific step number 2. In this step number 3, we are going to learn how to initialize the class correctly. To initialize the class, we have to define some of the properties as variables. So left side, you can see that conceptually, I have added 4 properties. These are the 4 properties we have. It means that we need to make sure that our class, when this class is being defined, there must be some property. And when we are defining some property in the step 3, there is a way that you need to define the class initializer. So you will say define initializer, and initializer is what is going to have various properties, and connection to class is that self, and then you can define various properties. So for example, this our class name. So these name properties, they could be anything because your class is specific properties. You are defining everything. Then you could say the self dot in the next step, we want to something our ML box specific. So we could say the algorithm, and that is your algo. So for example, we just call this algorithm is GBM, gradient boosting machine. Okay, and then we can also add another property that is called the apply AutoML, and we use this property as a false, means do not apply when this class is going to initialize. It means that these four properties which we have written here, they are properties related to the class, and whenever the object will be instantiated, this object is going to accept all of these properties. Remove this code for a while, we do not need. So we are going to define the ML object 1, which is type of ML box, and then we are going to see what it really looks like. Let's run this code. We are instantiating the ML object 1 of type class ML box. Run. At this point, ML object 1 has been instantiated of type ML box. If you look into properties, you will see that all four properties which we have assigned here, they became part of ML object 1. And if you run complete code, now the method was called and life is very good. If you would want to connect this training with this algorithm, we can actually choose the algorithm. So ML training is in progress, and we want to say with algorithm. So you could say is in progress with algorithm name algorithm. And here we could say dot format and self dot algorithm. So train is progress, and here will be the algorithm name. Now you see that as soon as we have used the self.algorithm within this method, the warning is gone. Means is this method definitely related to now class, because we are actually dealing with this class properties. If we run our code now, I will run directly, you will see that ML training is in progress with the GBM algorithm. If you define another object, name ML object 2, right now because our properties are same, they both are going to say same result, because ML object 1, ML object 2, they are identical right now, because during the initialization there is no change in properties. Properties are identical to each other, and that's where we need to think what is the way where we could initialize a class which has the variable properties. It means some properties are applied to object differently based on how the object wants those property to be set. And that will be the step number 4 related to our class definition and object creation. So we have covered in our step 3 the proper way to add the class properties in the initializer for now, and how we could utilize them in our code when we are instantiating the object. So now in the step 4, we are going to learn how to define these properties in a way where some of the properties are actually used for class initialization, and some of the properties are actually, they are not part of class initialization, but they can have property whatever the class methods or other properties is going to set during the further application within the class. So let's take this. So these are the initialized properties. So the way you are going to set the initialized property is that you make those properties set in the initializer. It means if we would want to set the algorithm, we could say we are going to use the algorithm as variable in the initializer. Same thing, the apply AutoML is actually you can set during the initializer, during the initialization of your class in the initializer method. Now as you see that we have added these two parameters in the initializer, and then both of these class is expecting something to be filled, because if you do not fill, you debug your code, as soon as you are going to initialize your class, you are going to get an exception. Exception is that please provide proper variables which can be set during the object instantiation for the class initialization. So we could say the ML object 1, first one is actually using the GBM, and AutoML we do not want to use. the second object, we want to actually use the random forest, and with random forest use the apply AutoML. Now if we look into how the ML object 1 and 2 are initialized, you will see clearly that ML object 1 has the algorithm GPM with apply AutoML false, and ML object 2 has the algorithm random forest and apply AutoML is true. And that's a big difference. Now just adding the initializer variables in our class initialization method, we have made these two objects unique to their own behavior, their own property. And if you look into the training method, now it knows that for the first one, it's using the GPM. For the second one, it's actually using the random forest. Self dot apply AutoML is true, then the variable is actually with a AutoML is equal to without AutoML. And if AutoML is true, then this is actually becomes the with AutoML. And here you can say algorithm and add this. And if we run this code, now you are going to see that GPM without AutoML, random forest with AutoML. So there could be so many things you could do, but the idea is that slowly, as you are going to apply more and more class properties within the variables, you have a lot more capabilities to be built in your methods. And that is very important. And that's where we are going to learn how to create an object which is configured depending on what types of initialized property you are going to pass into. So in this step 5, we want to make sure we learn depending on this is the initialization parameters which has been passed, how we can actually create our class which behave more towards given parameter. There is no hard and fast rule. The only thing what you can do is that you can add more and more properties to your class that will help your class to be much more functional. So we are going to add more properties. So we will say that let's try to use the supported algorithm. GBM, GLM. Here GLM stands for generalized linear model. GBM is a gradient boosting machine. We can also have the random forest. We can also use the naive Bayes. We can use XGBoost for the which is based on boosting machines, and we can also use the light GBM, which is another open source library based on boosting machine similar to XGBoost. Now what is going to happen is that the initializer will pass the algorithms. Based on supported algorithm, we will validate if we are going to perform that job or not. So we will say that the algorithm and which is defined by the step when the object is created. So we are going to use another property called self.applied algorithms, and this is a list, and that is basically the list of algorithms which will be used when the training is going to perform. So supported algorithm could be tens of them, but applied algorithms are those algorithms which we are going to set in the class initialization. So we have set this thing up. Now we need to make sure that object is instantiated. Then we need to configure our class, because there would be tons of methods you need to perform, but what you really need to do. So we are going to add a new method here called define configure, and that's where we will perform some of the discussion we have just covered. So we have added a new method called configure. So let's write the logic. Our logic is very simple, that if self.algorithm which is in self.supported algorithm. So if this algorithm is in supported algorithm, then what we can do, we can actually add that algorithm in the applied algorithm. So we could say self.applied algorithms will be .append, because this is list, and we will use self.algorithm. That's very good. Second, we can also say that if the AutoML is also enabled, it means we can add 2 more algorithms. It means the applied algorithms will have maximum 3 algorithms which we could try depending on given algorithm and apply AutoML. So the next step is if self.apply AutoML. Okay, if the apply AutoML is true, then we will look into for each, because we need to make sure which algorithm we need to select. So for each algo in self.supported algorithms, we will look into if this each algo not in applied algorithm, correct? Stay with me. If this is not in this list, then you can take this code self.applied algorithms dot append, and you will add that each algo. So this way we will have all the algorithms added into applied algorithms and there will be no duplication. But our target is to support maximum 3 algorithms. So we can create a new variable and we could say self.automl size, and our default size is 3, means in the AutoML we will have 3 algorithms. So we could write a code here. We could say if the length of self.applied algorithms is greater than or equal to 3. As soon as it hits 3, then we need to break from this loop. This is the loop will break. So rather than 3 here, we could say self.automl size. That's it. And this is what our configure method. So we have created this configure. Now the configure is going to set up the class properly, which can perform the training as needed. So now in the training, we can update our method if self.supported algorithm. If the length of supported algorithm is equals to 0, then we can write a message where we could say print training, and we can actually return something here. So we could say return none. However, if supported algorithm has one or more algorithm listed, then it's going to say ML algorithm is processing with. Now we cannot use self.algorithm because we need to actually provide the supported algorithm. So the simplest way is that we need to make sure we take this list and we join everything over comma. So we could say is what the list of all supported algorithm with algorithms, and here we could use algorithms and with or without AutoML. Let's first run and see what happens with GBM and random forest, if there are any errors or not. So here you could see that all algorithms are added here. ML training is in progress with all. So something is messed up with our logic. Oh, our mistake is here, not the supported algorithm. We need to say applied algorithm. That's oversight. So if applied, that's where it is. Now if we run our code, our logic was good, just printing had some error. You could see that no algo is applied for training. It means whenever training is started, this applied algorithm is not set, and that is not set because we haven't called the configure method. It means whenever we are going to instantiate the object first, we need to make sure we configure it. So dot configure, similar to that, we need to say ML object 2 dot configure, and if we run our code after that, now you know that ML training first is using only GBM because there is no AutoML. However, the random forest is also have support for GBM and GLM, and AutoML is enabled. So if we try to debug this code, we put a breakpoint here, run debug. Okay, ML object 1 at this point has no applied algorithms. If we go next step, now the applied algorithm is being updated. However, because of no support to AutoML, is only one algorithm. Now we look into ML object 2. There is applied algorithms are none because we haven't called the configure yet. Now once we call the configure, now you see that 3 algorithms are added. Now you can get an idea that how you are going to create a new method which will totally change your class activity. And that's what we have covered in step number 5, where we learn making our class extensible depending on how you would want to perform action within the class. Remember, we haven't changed anything here. Just adding the config method and applying the logic we would want to apply here, we have achieved a very different functioning for each of our class instantiated object, ML object 1 and ML object 2. In step number 5, we have covered this. The step number 6 is going to help us understand more about the class initialization. So we have learned the init method initialize our class, but sometimes you need to actually control the initialization of the class. So now you have two classes, one is class A, one is class B, and you want to create an object, and depending on whatever your action is, you either want to instantiate the class A or you want to instantiate the class B. And that is what all depend on while you are going to initialize your class. So in order to control it, we need another class. So now I have added another class called the main. That class main is actually going to help us to either instantiate the class A or the class B. It means when the object is going to be created based on class main, it is actually not initialized yet. And that's what we need to learn in step 6. So we already have this class ML box which does a lots of things. Now we need to create another class. So class A is our ML box here. Now we need to create the class B and let's call it data box. Again, so this data box class is a very simple class which is actually performing the data specific operation. So in the initializer, we are going to select a particular action which our class is going to perform. So first we need to define the self.name, we call it data class, self.data class property, self.supported actions and data specific actions. So let's call them like data is skewed or not, data has anomaly or not, data has drift or not. So these are supported action, and we can say whatever is the given action. So this is action which is going to be coming out from the initializer. And finally we could say based on action, it is the active action is equal to what is being set here depending on our logic. Now we need to write the very simple config method. So let's add the config. So define configure if self.action in self.supported action, only then we are going to say active action is equal to self.action. That's it. That's our config method, which is very similar to this config, but for the keeping the similarity, we are keeping data box which has the configure and the ML box has the configured and training, and it has some properties here, and only one property is for the initialization. So that's where our data box class stands and ML box class stand, and they both are using initializer. So now very first time you are going to learn the another method which is called the underscore new. So we have new keyword and we have init keyword. So whenever you are going to create your class where the initializer is using the new method, it means the object which will be created, that is going to not initialize the class. It will just create the instance of the class. So let's create the class. So we have class control box, and here we will say define, and we are not going to use the init, we are going to use the new. And as soon as you use the new, you will see that it actually has a keyword class, various arguments and KW arguments. It's a very different than the initializer. And depending on our new, we could actually initialize whatever class we would want to create depending on whatever our options are. So let me write the code here, and then whenever I will use the object, you will learn it better and it will also make you clear. So what we want to say is that whenever this control box is used to instantiate the object, you need to tell what is your choice. So a choice is going to be passed, and we could say if choice is equal to data, then you are going to return the data box and all the parameters which are passed in the initialization of the control box. There you go. Then you could say else if choice is equal to ML machine learning, then you are going to return the ML box with all the parameters, otherwise else return none. So that's our control box class. It is used to either create this class or create this class. So how it is going to be used? So as you have seen earlier that we were defining our objects like this way. Let's comment this for a while. Create the ML object now. ML object is going to use our control box. At this point, if you see, control box is showing a warning because it's needed a choice. So we could say actually I need choice S of data. Then we will create the data object and we could say control box and this will be the ML and this will be the data. So we have ML object and data object. Let's debug and see what happens here. There are some errors. Let's see where the errors are. Colon is missed. Okay, there you go. So ML object, we are trying to create this object. Let's go next. There is some error. And if you see here, that it says that, hey, if you want to have the ML box, you actually need to provide the algorithm and apply algorithm. Otherwise, I will not be able to create the ML box for you. So dynamically, we can actually pass whatever ML box parameters are needed to make sure we could create our ML box class. If we pass this thing, now we run complete code. Let's rerun it. Go next. As you see, ML box is actually created and ML box is actually using everything as it is for any other object which is instantiated based on ML box. Remember, we haven't even run the config and training, so that's a different scenario. We need to follow a little later. But now we look into the data box and now data box is going to give us error because you actually need to provide the data box action. What kind of action you want? Otherwise, class cannot be used to instantiate new object. So in that case, we need to say with the data, our action is actually we want to provide the SKU. Now, if we run our code, you will not see any error because we have instantiated ML object and data object with a very different parameters, but these objects are actually automatically creating us either ML box class based object or the data box classes object, and that is where we have used the new keyword. And this example is a live example where you could understand how we are using the control box class to get what we want. If we want to complete this code, then we just really need to say mlbox.configure, then mlobject.training. And same thing with the data object. If we try to configure, that's where the configuration is. And then if you add the process, like a data processing method, then you can say what you are doing. I think you can write that code very easily by yourself. If we run this code, you see that ML training is going on. So now you have very good understanding that how using the new keyword, we can actually achieve whatever target class instantiation we want. Because remember, the new is not initializing the class. It's just creating the instance of that object without initialization. And initialization is done later. So this is what we have covered in our step number 6, the use of new as well as the init keyword. So the step 7 related to our class methodology includes the class inheritance. It means the relationship between two or more classes where one class is the parent class and the other class is the base class, the class which you are using. So until now we were keep using all the classes, they were all the base classes. And as soon as we brought the parent and child relationship, now we really need to make sure how these two classes are going to connect. So very simple things related to class inheritance. When you are trying to inherit the properties from a class, then the class which gives the property became the parent, and the class which takes the inheritance or takes the property from the parent became the child class. And this sequence can go on, parent to child, child to another child, then the parent class will become the grandparent for this class. So we do not need the control box, we do not need the data box. So I will remove this and I will keep our ML box class. So this is our parent class, for example, and we have various algorithms which we apply. So now what we need is that we need to come up a method so that we can actually apply the various algorithm. And the best way to do is each algorithm has its own class. So we could say class GBM in action, and GBM in action class is actually inherited from the ML box. So ML box properties and methods are going to be shared with GBM here. And as of now, we could say that GBM in action is actually the class which is going to use the initializer which is available in the parent class. So we need definitely the initializer. So first we need to define the init. As one more thing, before even we try to define the initializer, if you do not want to do anything, then you could say GBM in action pass. Means this class doesn't do anything. Second, we can create another class. We call it GLM in action. That is also ML box, and you can again define the initializer for that class. And one thing you need to learn, that as soon as you are going to use a class as a parent class, or this class is going to inherit, is if you use the method, you can use the super keyword, and super keyword is actually going to give you the hook to your parent class. And as you see here, that all the properties, super keyword is actually giving you connection to the parent class. So you see that supported algorithm, all these properties and all the methods related to the class is all available for you, and that's where you have access to initializer as well. So you could say I am interested into the initializer, and as soon as you are going to select the initializer, now you need to pass whatever you would want to perform. So remember, this is the GBM or the GLM in action. It means if you are going to perform the GLM, it means your algorithm is already the GLM. So only thing you need in order to add other algorithms is that you need the support for apply AutoML. So you could say I need to know apply AutoML is part of initializer in this GBM in action. So if GBM in action has to support apply AutoML, then you need to pass, otherwise it's just gonna be using the GLM. Similar to that, you can actually create a class random forest in action, and this is going to use the random forest. So we have three different classes which we have created. They are all child classes because they all inherited from the parent class, which is ML box. Now, if you have another option where you could say, oh, whenever the random forest is going to be instantiated, I do not need to apply the AutoML. It means you can say by default it is false, and the initializer does not need any property to pass. So if you will create these different objects, so you will say GBM object is equal to GBM in action, and if you see here, it actually expecting give me the algorithm or give me the apply AutoML. Pass means feed me everything related to my parent class. And if you will say I would like to use the GBM and I do not want to use the AutoML, your GBM object is initialized. Then you say GLM object is equal to GLM in action, and here in GLM in action, you have to provide AutoML support or not. So you could say, yes, use the AutoML. Now your GLM object is initialized. We do not see any warning. Then you say your random forest object also is going to use the random forest in action class, and you can initialize it without any parameter because it has no support for AutoML. If we try to go ahead and initialize all of these three variables, let's look into GBM object. Actually, it is exactly everything what we have supported. As soon as we will use the config and the training, GBM object is good to go. We look into the GLM. As you see here, the GLM object is also set as you are expecting, and you can also add the random forest in this list. Okay, let's complete the code. So class inheritance, we have seen 2 level. In the step number 8, we actually going to go and try to create the class inheritance up to 3 level, where you have good understanding about the parent class as well as the grandparent relationship. So before we jump to next step, I just wanted to make sure that so far we are using the methods within the class outside the main. However, you could actually call those methods inside the main and they all going to work, because the concept of main is very important in Python, and I have a very dedicated video which really talks about why we are using main and different ways to learn and apply main effectively. And if we run this code, there is no more problem. If you will do same thing for glm object here, dot configure glm object dot training, similar to that, random forest object dot configure and random forest object dot training. Run and everything is good to go as you are expecting. And step number 7 is the base to be step number 8. So in this step number 8, our class inheritance is actually exposed to multiple classes. So class inheritance is using multiple classes hierarchy. It means we have parent class, we have child class, and this is child for that. So this became the grandparent class. So we could say the relationship between here to here, and then relationship is between here to here. So the relationship between this class and this class is basically the grandparent and the grandchild. We are going to use same ML box class. We are also going to use the GLM in action. However, let's just remove one or two classes. Let's keep these two classes. Now we are going to create a new class. Is called the boosting machine, and this class is actually inheriting properties from the random forest action, and let's make it pass. It means it's just a class which taking everything available in the random forest. If we would want to actually use boosting machine to either select random forest, or if you say that this is actually the gradient boosting GBM as well as the random forest, they're based on boosting methods, you can use the new method here and you can select whether you want to use the random forest or you would want to use the GBM in action. We have already learned that earlier. Let's remove all of these and we are going to create the new object called the boosting machine object, and that is going to use our boosting machine. And let's put a breakpoint here, run the code. As soon as you are going to go further, the boosting machine is already using underneath random forest and everything as it is, no change. So the relationship between the boosting machine all the way to ML box is a grandchild, grandparent. However, as you see, the connectivity is going through random forest to ML box. So for the sake of completeness, let's try to run the config and then let's try to complete the training. And we have access to these two methods because of link chain built between the class inheritance. Run this code and we are good to go. Now, if you would want to select whether we would want to use the GBM or the random forest, the code is really very simple, which is related to the control box code, which we have covered earlier. So I will go to control box code. Here, take the exact code, add into the boosting machine. Here, we will do not pass anything and we will select here either GBM in action. The choice is GBM, we will use GBM. If choice is random forest, then we are going to use the random forest here. That's it. Here, as you see, we are experiencing the warning because the self here does not have any parameters. So we need to make sure we either support the parameters or we do not support the parameter, because we do not really need it in order to get the random forest, because everything is already set inside. So only parameters we needed for the GBM in action. And here the apply. So if we take the boosting machine object and we instantiate it, as you see, it's expecting some of the parameters. So we need to provide the choice. So if we say we need the GBM, my mistake, is a GBM. So we can say BM GBM object, and we can also say BM random forest object, and this is random forest. And remember, we have already learned that if we will not provide the proper parameter, we are going to get errors. So let's debug the code. we are going to definitely hit the error with the BM because it's expecting some of the parameters which we haven't passed. So in the GBM, we need to say whether we want AutoML or not. So that's one problem we need to solve. So we could say, yes, we want the AutoML. Let's run this code now. We should not have issue with GBM. Now the random forest, as you see, there is no problem whatsoever because by default, looking into the random forest boosting machine object, everything set as random forest. For the GBM, everything set as the GBM. So if we try to use the proper configure and training specific to each individual object, they both is going to work without any problem. So this is just an issue. So this will be BM here, and then same thing is going to be the random forest here. So random forest and random forest, and everything good to go. As you could see, GBM, this is using because of true, and here random forest only using random forest. There is no AutoML. So that is what we have covered in multiple class hierarchy with the class inheritance in step number 8. So in the step 9, we are going to learn creating a class with a very different way, and that is a way of using the type keyword, and by passing the class name, whatever you would want to create at that time, base class or classes, you can pass the classes, list of classes, and you can also provide the dictionary. And dictionary is where the initialized variable or the variable which you are going to initialize the classes that you have to provide. So let's go ahead and remove all of these classes we do not really need, and goes back to original MLBox class. So this is MLBox class, and if you look the initializer, it actually uses the algorithm and apply AutoML. So if we would want to create a class with the type class, we really need to have the dictionary in order to make our class initializer working. So let's create a new method called define init. We have self, then we are going to provide the algorithm, and we are also going to provide the apply AutoML. This, and again our logic is very simple. Self dot algorithm is equal to algorithm, self dot apply ML is equal to apply AutoML. So that's our initializer method. Now let's take a look into our logic. So we say class is equal to type class name, the class name you would want to give, then you would want to use the base classes. So you can say bases, and then the dictionary. So dictionary is our init. So let's try to create a class. It's called the MLBox new. That's our class name, and we would want this class MLBox new use the type MLBox new. That's the class name. Then we want to say base class. We would want to use the MLBox, and because the MLBox class can be a collection of classes, so we need to put this thing into a parenthesis, and we need to make opportunity to add more classes as needed. And finally we need the dictionary. So dictionary is this init. It means for this class we need to provide the initializer, and initializer is going to be the dictionary which we are going to provide, and that is the init, and that is the class which we have just defined. MLBox ML new. So this is the MLBox new. I debug this code. At this point we look into the special variable. You will see that there are two classes, MLBox new and MLBox. So we have created a new class called ML new, and that class is actually inheriting the property as exactly as the MLBox, and it's using this initializer. So if we go ahead and try to instantiate an object, so we can say ML object which we want to instantiate using the MLBox new. MLBox new class, if we just try to instantiate and go ahead and debug this code, you will see that there is error because immediate when the initializer ran for this MLBox, immediate requirement for algorithm and the auto apply algorithm was needed. We need to provide those parameters. To solve this problem, we just need to say that our algorithm is GBM and we want to have the true, means support for AutoML. Now we run the code, debug, ML object is created, and which is actually using these two parameters. This class is actually using the ML box as the base class, but this ML object does not look any way similar to ML box which we have seen. None of these properties are initialized. To understand that change better, we have to go and we have to add another class. Let's create another class called ML Ops, which actually perform the monitoring. And it has a very simple method called monitoring. And in the monitoring class, just print it ML Ops 2. And that's our very simple class ML Ops. And what we can do is that we can actually take this ML Ops class and we will inherit ML Ops in the ML box later. But right now we create this ML box new and we actually provide the base class as a ML Ops. Now if you take this class, debug it, if you are going to look into the ML object again, ML object has these two variables, ML box new. However, if you will try to say in the ML object, I would want to perform the monitoring method. Let's debug. Next step, as you could see that console, the monitoring has been printed. It means the ML object was able to call the monitoring when we have defined this ML object. However, when we were using the ML box, if you say I would want to use the training here, ML box, and training is a method for ML object, debug, initialization, training is an error because attribute error. And if you look into the output, it says that ML box new object has no attribute to applied algorithm. The type supports ML box and ML ops. So we could say, why can't we use ML box and ML ops? Let's use the monitoring and let's see where the error is going to happen. Debug the code again. Next line. Monitoring is accessible, we did not see any error, and we are still seeing the error into the training. And reason is that we are seeing the error, which is because applied algorithm is not set. It means if we would want to access the ML box in the initializer, we have to actually set other algorithm. It means we need to go ahead and we need to say self.apply algorithms, and we need to set whatever algorithm we would want to use. Oh, very good, because only applied algorithm was needed. So once we set it up, apply algorithm, which is just an internal parameter, but it doesn't need it in the initialized variable, we were able to get that applied algorithm. And here the algorithm is not supported. So we need to say that, hey, can we make sure that configure is there? So if we use the ML object dot configure, and if we run this code, now in order to run the configure, we have to have support for supported algorithm. So the training was working because training method only needed support for applied algorithm. So we have added apply algorithm. Our access to training method was available, but configure failed because it needed the supported algorithm. So you can get an idea that in order to access the function, you need to make sure you have proper properties accessible in the class. So that's one way to understand. Second option is that you actually create this class based on ML ops, and here you can actually take this ML ops and add as a parent class to ML box. So ML box is also inheriting all the properties from the ML ops, and here in the ML box new you are using ML ops. Now if you run the code, and as you could see that ML box does not have access to configure because ML ops. So now you can actually use the ML box here, run this code, and it just required the supported algorithm. So you can get an idea that there are multiple ways you could bypass this problem. Either have multiple of methods available as a base class, or you can chain them using the inheritance. So many things you could do, and not it is very practical way to do it, but I just wanted to show you that how you could use the type keyword and you can create the new class and depending on how deep you would want to go, you can explore your available options in this way if you are using this method to create your class. And the step number 10, we are going to use the data classes where we do not really need to use the initializer method and just apply the data classes. And that's a very new concept depending on what we have covered from step 1 to step 9. So we do not need any of this code right now. So I will go ahead and remove this all. Back to very basic. First thing, what we need is the importing data classes. So from data classes, import data class. In the next step, we are going to define our class. So class is ML box, and within the ML box, we have no initializer. We are just saying the algorithm is equal to, algorithm is going to be the string, apply AutoML is going to be the bool. So that's our class. The method is going to be the define, training our method, and we are just using the same method for depending on algorithm and AutoML. So you see, first thing, we are not using any initializer, and in order to make it work, we have to annotate this class as a data class. So this is a data class. It means that now we have ability to avoid the use of init, and we can just pass variable like this directly. At this point, we can create the ML object, which is the type of ML box. As you see, there is a warning, which means we need to apply the algorithm as well as the apply AutoML. So we could say we want to use the GBM and false for AutoML, ML object dot training. Run this code, is working as it is. So even the full class, what you really had, you could avoid in your class. To set up any of that, you could just pass the variable, and you can also hard code the variable. So here you could actually say that supported algorithms are GBM, GLM, and you could say random forest. And if you run this code, this is not going to have any issue with you. It's just working as it is, because we are not using the initializer with self. All the variables are available in the class, and whenever you want to access them, you're still going to use the self dot variable or the property name. So that is what we have learned in this step number 10, where using the data classes, you can create your class little differently without using any initializer. The full code which we have covered in this video is available in this DeepWorks GitHub repo and in this Python classes markdown document. All the step 1 all the way to step 10 are documented, which you could just copy and paste in your Python program, and you can follow the tutorial video. So that's all I had for you in this video. If you have any suggestion or comment about this video, please do share with me, and I will definitely going to follow up with you. Once again, I do appreciate your time you watched this video. Thank you so much, and I'm looking forward to seeing you in my next video. Until then, thank you so much.